Hi everyone. Today we are going to present our hydraulic group project and we are from group 3. Okay, now I am going to introduce my group members. My name is Sridhar Analaki Tangamani, CF230129, Muhammad Faiz bin Ahmad, CF230206, Muhammad Faris Aiman bin Aziz, CF230217, then Sharvindran Analaki Kalayarasu, CF230196, last Amin Said, L Taib Muhammad Alamin, AF230098. Now I will explain about the introduction. Hydraulics is an interesting field of study that deals with the real world uses of fluid, mainly liquids, in motion. It examines the flow of liquids through river, canals, and pipes as well as how they are held in check in tanks and dams. It is closely related to the theory of fluid mechanics. Then, hydraulic concepts can be applied to gases when the density changes are negligible. The hydraulic system is widely used in trash trucks and car brakes. Open channels are surfaces that are exposed to the atmosphere. They include both man-made beaches and naturally occurring watercourses like rivers. There are two factors that affect the different flow rates of rainfall and runoff. Swales used to biofiltration and ditches adjacent to rivers, streams, and motorways are few examples. Open channels are advantageous for irrigation and natural drainage. As their name suggests, open channels are essentially windows into surrounding environment. Now I will explain about the problem statement. Numerous factors including the location's topography, height above sea level, channel width, channel slope, channel surface type and weather can affect a flow's discharge value. Then, determining a flow's discharge is crucial because if a channel is not precisely designed and had errors to the necessary regulation, it could be result in flooding in the area. And for the objective, number one, using Manning equation and the continuity equation Q equals to AV to calculate the channel's discharge value Q under various weather circumstances. Second, to determine the type of channel that was used using the Manning coefficient table. Third, to figure it out the flow and flow type fraud number equals to FR.
The study focused on the drain channel adjacent to the C3 building at UTHM, which serve covered walkways for people heading to Building B at UTHM. Additionally, a nearby toilet influenced the selected drain channel for this study. Key features of the drain channel. The first one is shape material is semicircular and made of concrete. The second one is Manning roughness, coefficient 0.017. The dimension is the height of semicircular drain is 110 millimeter and the diameter is 220 millimeter. The water flow height is 73 millimeter. Data collection detail, as you guys can see, date and time is 4 June 2024 at 12 p.m. The weather is cloudy. Procedure, the group members fill the channel with water to calculate the flow rate due to the lack of natural water flow. Environmental condition is no leaf and grasses obstruct the channel, ensuring accurate velocity measurement. Measurement point we take at inlet, middle and outlet of the channel.
Hi and welcome. My name is Sharvindra Analaki Escaliarasu and my matrix number is 230196. And for my part, I'll be presenting about method and equipments. So in this case study, there are few methods and equipments that have been utilized to ensure the most accurate and optimum result of the experiment. This method and equipments are listed below, which is firstly is ruler, second water level tube, and third picture is will be shown about stopwatch, and fourth measuring tape, and finally fifth one is ping pong ball. Next, we will see about the drainage slope determination. So, an instrument is to match elevation of places too far apart is water level to span a spirit level. By it measuring the height of the water of two distinct location and the distance between them, the slope of drainage may be calculated using the notion of water level. Then our group also used to the tube and the water method for this. This is the most basic water level method, consisting a clear tubing segment that is filled with water. The remainder of this tubing rested of drainage ground, and the tube ends were kept vertically during the entire procedure. Next, with the distance between them set at 2 meters and the water level heights at the two distinct fixed sites, which is H1 and H2, were measured. So, for your knowledge and our knowledge, the water level of and at the both end will be kept at the same elevation regardless of whether they are adjacent. And lastly, the ratio approach can be used to calculate the drainage slope. Furthermore, we will see about the drainage geometry determination. So the water level tube was placed along the inner side of the drainage to determine the curve of the drainage. Next, a measuring tape also is used to determine the tube's length. And owing to the narrow drainage channel, a ruler was used to measure the drainage top width and bottom radius and depth. So all the measurements were taken on this site at the three drainage section, which is upstream, middle, and downstream, within the 3 meter reach to ensure the accuracy. So these data were used to determine the drainage area and weighted perimeter, which are displayed in the report analysis sections. So next we'll see about the on-site activities and investigation. So to make the selected drainage function like a regular channel, so first we must fill it with water, and then a ping pong ball was placed upstream within the 2 meter reach that we measured. And to put it briefly, the ping pong ball was chosen since it is lightweight, so and its weight can be discarded. So the ball's journey from the upstream to the downstream was timed. And finally, the goal of this exercise was to watch the drainage flow and determine the approximate flow velocity. Thank you. That's all from me.
Okay, Assalamualaikum. Okay, this is the formula that we use to completing our calculation. Okay, at the first, we use the formula for the discharge. We use the continuity that Q equal to the flowing areas times by the velocity. The second one is the formula for velocity. We use the Manning velocity, that V equal to 1 over N A at power of 2/3, then the S naught the power of 1 over 2. Okay, this is the dimension for our channel. Okay, the diameters is 220 millimeters. We change to meter is 0.22 meters, and then the Y naught is 73 millimeters. We change to meter is 0.073, and then the 2 theta equal to 151 degree. Okay, for the normal depth or Y naught equal to 0.073 meters. The diameters is 0.22 meters, and then the Manning coefficient or Manning roughness N equal to 0.07. Okay, at the first we find out the flowing areas. We use the formula that A equal to D squared over 8 times by 2 theta minus sine 2 theta. Okay, after that we get the flowing area for this channel is 0.912 meter square. Okay, after that we find out the wet perimeter. Okay, the wet perimeter equal to theta times by d. This is for the circular section or the semicircular section, and then we get the wet perimeter equal to 0.29 meters. Okay, this is the solution for to find the hydraulic depth. Okay, as we know, the hydraulic depth equal to A over by T. Okay, for the T for the circular section or the semicircular section, the T is equal to D sin theta. Okay, after that we substitute into the formula. D equal to 0.2 meter square divide by 0.22 meters and times by sine 75.5 degree, and then after that we get the hydraulic depth equal to 0.93 meters. After that we find the hydraulic radius. Okay, as we all know that the R equal to A over P, and then we found that the R value equal to 3.145 meters. Okay, for this velocity we use ping pong ball for 3 trial per section. Okay, the formula is V equal to D over by times. D equal to distance that we choose for 3 meters per section. Okay, this is the velocity for inlet section we get. Okay, for the velocity inlet at the first trial we get 0.42 meter per second, and then for the second trial we get 0.41 meter per second, and then for the third trial we get the 0.4 meter per second, and then for the V inlet we find out the average for the 3 section, and then finally we get the velocity is equal to 0.41 meter per second. Okay, this is for the inlet section. Okay, this is the velocity for middle section. Okay, at the first trial we get the 0.44 meter per second. At the second trial we get the 0.41 meter per second, and then the last trial we get the 0.42 meter per second, and then we average it, and then finally we get the velocity for the middle stream is 0.42 meter per second. Okay, this is the solution for find the bed slope or S0 for our channel section. Okay, when we get all the values except the S0, we can find the S0 by we set S0 as unknown. This is the solution for the bed slope for inlet section. Okay, we found out the S0 for the inlet section is 0.0065. And then this the solution for bed slope for the middle section. We get the S0 value is equal to 0.0073. This is the bed slope for the downstream. We get the S0 value for the downstream is equal to 0.0068. Okay, to find the water flow rate, we use the continuity equation that the Q equal to A times by the velocity. A is the flowing area.
Assalamu alaikum. My name is Ahmed Said. I will continue what my friend started. Conclusion. In conclusion, hydraulic systems involving open channel flow are crucial for various sectors such as water supply, drainage, and irrigation. They offer extensive insight through their application to design and optimize the system for safe and efficient operation. Through understanding of open channel flow principle is essential. By applying hydraulic principle alongside open channel flow, engineering and technicians can effectively construct and maintain these systems, ensuring a reliable flow of water and other fluids.